Hello, hey everyone, what's up? Hello, hi. Am I audible? Let me know if I'm audible, guys. Guys, let me know if I'm audible. Chat section में बता देना audible हो कि नहीं. So namaste. My day was good. Let's wait till everyone joins, and my day was good. Okay. Okay, I'm waiting for everyone to join in. Once everyone joins in, I'll tell you. मैं बढ़िया हूँ. Probably I'm thinking of taking a tries in future. Trie, try rather. That is what I'm thinking of taking. Going forward, I'll be also taking something like graphs, object-oriented programming, thinking. So binary search. So it's gonna be a master class. The master class that I took on recursion, I took on everything. Before that, for everyone who's watching out for the first time, let me just explain. Let me just introduce you myself. My name is Raj Vikramaditya. I'm known as Striver in the programming community. I am a competitive programmer in and out from every side. I'm a competitive programmer. Software. I currently work as a software engineer at Media.net Direct. Prior to this, I was working with Amazon. Also, I'm a candidate master at Codeforces and a 6-star rated coder at CodeChef. I have a couple of years of teaching experience, and I also run a YouTube channel which is around 1 lakh plus subscribers. The subjects that I generally take at UC or at Unacademy and CodeBeyond are competitive programming, data structure algorithms, C++, interview preparation, and if you are willing to take any of the Unacademy subscription, make sure to use the coupon code STRIVER in order to get the 10% off. So binary search masterclass is what I'm looking forward. What's the schedule? Today is 13th of September. So today I'll be teaching binary search explanation. So I'll be starting off with the iterative explanation. Then I'll be moving on to the recursive binary search. Then I'll be telling you how to handle overflows. Once we are done with these things, these specific three things, I'll be teaching you something which is known as lower bound. I'll also be teaching you something which is known as upper bound. In C++, there is a C++ STL that tells you about lower bound. There is a upper bound STL that tells you about upper bound. So we will be learning how to implement those, because I'm very much sure that there are number of Java people. So I'll be teaching you how to implement something like a lower bound as well as something like an upper bound. Okay, so that's what I will be teaching today. And right after that, we will be doing one problem, which is finding the square root of a number. So that will be for today. Probably I'll be taking 190 minutes to 120 minutes, depending on how many time, like if you have any doubts, it might extend beyond that. So that will be for today. Tomorrow we will be doing medium problems on binary search. Now when I say medium problems on binary search, tomorrow we'll be doing probably 6 to 8 problems from lead code on binary search. So all the problems done tomorrow will be on arrays, okay, on sorted arrays. And then comes 15 September, where we will be doing hard problems on binary search. Now when I say hard problems, again I'll be doing 5-6 hard problems. What are these hard problems? Basically something like a monotonic increasing function, monotonic decreasing function. How do you, like, apart from sorted array, where can you implement binary search? All those kind of problems will be done on the third day. So if you think you know binary search, you can probably join in tomorrow. If you are like comfortable, you don't need to attend. But if you are someone who's new out there, like someone who is starting off, who just knows what is binary search, I'll highly recommend that you should definitely watch this stream in order to understand everything. Okay, cool. Operating system नहीं आता भाई. I don't know operating system. Like, I'm not a very big. Okay, Sai is teaching DP, so yeah, you can learn from him. So before moving on, just a quick quick announcement. So there is a career as a developer subscription that is going on. It will cover shows around placements, beating the odds to get a good placement, life problem solving, over the weekend projects. So it is a year-wise subscription which comes at around 899 if you use the coupon code again Striver. So basically over here you can like if you want to talk to me directly, because over here on YouTube it's not possible. So over here we get a lot of shows where you can directly interact and you can take direct guidance. If you want a mock interview of yours to be happening, you can again request us. We'll be taking your mock interview. If you want your resume to be reviewed, you can ask us. If you want project to be reviewed, you can ask us. So there's a lot of shows which focuses on everything that's related to software development. So you can definitely check it out. It'll hardly cost you 899 for 1 year, I think, which is very low. And I specifically take shows which are related to college projects every Friday night at 10 p.m. Again, comes under the same subscription. And my batch currently is going on, that is Placement 2021, 4-month track to crack coding rounds of top product-based companies, which again has started on August 1, completely in English. If you want to join that, you can check out the links in the description. You'll get it. And if you're new to this channel, make sure to join the Telegram group right at the end. If you're new to this channel, make sure you subscribe to it. स्ट्रीम सबसे पहले तो स्ट्रीम को लाइक कर दो. सबसे पहले स्ट्रीम को लाइक कर दो. Like, make sure you like the stream. If you're new to the channel, subscribe and click on the bell icon. Without wasting any time, let's get started. Okay, so just wanted to know how many of you know binary search. Mohit, I will be doing some extra problems apart from Take You Forward binary search playlist. Like in Take You Forward, I haven't implemented lower bound and upper bound. I haven't talked about the overflow condition. Also, I've just implemented 3 problems from the hurdle section. Over here, there'll be 5. So some problems might be from there, but I'll also try to do some more extra problems. Okay. Cool. How many of you know binary search? Can I get a yes if you know? Can I get a yes if you know binary search? Like, how many of you know binary search? Can I get a yes? And how many of you do not know binary search? Can I get a no? So just to get a head count, what is my audience all about today? Just to get a head count, what's the audience all about today? Okay, looks like everyone knows. I know a pretty bit. Okay, yes. Okay, since everyone knows binary search, but still I'll have to teach, because if someone is watching this lecture who's very new, because this lecture has been specifically demanded by a lot of beginners, that is specifically beginners. So let's understand binary search. Let's understand this concept, binary search. Okay, assume the array is, for everyone who knows binary search, probably you can try implementing lower bound and upper bound. We'll come to that. Assume the array is, like, I'm not talking binary search, I'm just giving you a assumption. Assume the array looks something like this. Okay, just assume the array looks something like this, and I give you a number x equal to, let's assume 9. Okay, and I tell you, give me the first occurrence. Give me the first occurrence of x. Okay, so logically the first occurrence of x will be at the index 4. Okay, will be at the index, logically the first occurrence of x will be at the index 4. Now, how do you figure this out? The first way to figure this out is linear search. Okay, since they are asking you the first occurrence, the best way to do this is linear search. Okay, so how do you do a linear search? It's very simple. For everyone who is just starting off with coding, you should be knowing this. I should be lesser than n. You basically linearly iterate, and you say if array of I is equal to x. So I'm saying, okay, I'm basically traversing on every element. First I travel at the 0th index, then I'll travel at the first index, then I'll travel at the second index, then I'll travel at the third index. And since you people know that the array is indexed in terms of 0, 1, 2, 3, 4, 5. So it's from 0 to n minus 1. So I can easily traverse, and if at any moment array of I is equal to x, what I can do is I can definitely probably keep a variable flag, or you can directly print. You can probably keep a variable flag equal to -1, and you can say flag, hey flag, why don't you capture I? Why don't you capture the index I? Once you have captured, why don't you break out? Okay, so I'll capture I, and right after that I'll break out. So at the end I can simply print flag. Yes, at the end I can simply print flag. This is what I'll be looking to do. Yes, this is what I'll be looking to do. So if I print flag, yes, I repeat, if I print flag, that will make sure if do they have a highlighter? हाइलाइटर नहीं है, कोई बात नहीं. So basically if you figure this array of I to be equivalent to x at any time, that eventually means that the index I has the element x, so you can store that into your flag and you can break it out. Okay, and if this line never executes, then the flag stays as -1, which determines that the element was never ever present. So I can easily print -1. Now what's the complexity of this linear search? So can I say the complexity of this linear search is big O of n? Why is the complexity big O of n? Because I'm running a loop which starts from 0 and that goes on till n. Assuming, yes, assuming this if statement never occurs. Yes, assuming this if statement never occurs, I can definitely say if that never occurs, the I is going to start from 0 and the I will go on till n-1. Hence, taking a maximum time of big O of n. That is the worst time that this array might take. At the worst time that this array might take. But the advantage of linear searches, yes, the advantage of linear searches, it works in any array. Remember this. The advantage of linear searches, it works in any array. I repeat, it works in any array. It does work in any array. Okay, perfect. So everyone has understood. Has everyone understood this? Has everyone understood this? Okay. So has everyone understood the first occurrence of x वाला concept? पहला occurrence of x का concept आ गया clear? Striver bro, you are so good. Your tree series helped me a lot. Thank you. Okay, everyone has understood linear search? Okay. For people who know, please don't get upset, because you need to understand it's something which I'm teaching from extreme basics to extreme advanced. That is why it's a master class. Okay, so that's about the binary search. So everyone has understood binary search. Okay, now let's move across, and since we're learning binary search, let's first learn it for something which is, now let's assume like the array is unique and sorted. Okay, remember the binary search works on sorted arrays. The binary search works on sorted arrays. Okay, and as of now, just to start off with, let's consider that this array is only having unique elements. Okay, let's consider this, that this array 1 3 4 7 9 11 only has unique elements. Okay, as of now I'm considering it to have unique elements. After that I will tell you about duplicates and everything, but now let's learn about unique elements. Binary. Now, do you know what do you mean by binary? It basically means 0 or 1. Basically binary in computer means 0 or 1. So it basically means either there will be or there won't be. Okay, so why do we need a sorted array? Let's understand. Now whenever I say x equal to 9, binary search is very easy. What binary search says is, okay, I need to search in the entire array. Yes, I need to search in the entire array. So what binary search says, okay, I'll keep a pointer here. Okay, and I'll keep a pointer here, and if I write down the indexes, so it's basically 0 1 2 3 4 5. I'm keeping couple of pointers. Okay, now you will try to find out the middle, assuming this to be the left pointer, and we call it generally in binary search as low, and the right pointer we generally call it as high. Okay, so we will keep this. Now what I will do is, I will say, hey, why don't you get the middle? So I'll be like, okay, let's get the middle. So it will be the middle. We will always take low, we will always take 5, and we will do like always the low and high, and we will divide it by 2. 5 by 2 comes out to be 2.5 something, but we generally take integer truncation. So the middle is pointing here. Okay, the middle is pointing here. Now it's very important that we check, yes, we check if this x equal to 9 is this element. Is x equal to 9? Like, no, it's 4. So I know that at the middle, like wherever the middle is pointing, that does not contain 9. And if it doesn't contains 9, now it's the time to shrink the array. Now it's the time to shrink the array. So can you tell me one thing? This 9 is indeed greater than, yes, this 9 is indeed greater than 4. Now if you carefully observe this array, if I draw a linear graph or linear like slope, can I say it's linearly increasing? So if the 9 is greater than 4, so can I definitely say, I repeat, can I definitely say that the 9 will never lie on the left array, right? It's never going to lie on the left array. Does it make sense? It does absolutely make sense, because if 9 is greater than 4, I know everything to the left of 4 has to be smaller than 4. How will I get a 9? So what you'll do is, you will basically omit the left part. So let's omit the left part. So I have omitted the left part, and your array will shrink to this much. And whenever your array shrinks, you will just take the low pointer and you'll place it right after 4. If you remember, there was a 4 and that was pointed by middle. So you'll always take low and you'll place it 1 after the middle. Okay, so that's what you'll do. So this is what my array currently looks like. So again, let's erase the previous ones. So this is what my array looks like. Now this is the moment you can say, what's the middle? The middle will come out to be, again, 3 plus 5 by 2. Hence the middle comes out of the 4th index. That's this. So this is the middle. Now if this is the middle, which is 9, can I say that this 9 is equivalent to this 9? Hence, I repeat, hence, instead of cancelling any further arrays, you say, hey, I figured out my answer. Why don't you just store it and break out? So probably I can store this into some index 4 and I can break out. So in this way, you can easily figure out where does the element exist. I'll take some other examples, but like, have you understood how did I cancel some part of the array? How did I cancel the left part of the array? In the next example, I'll show you how to cancel some other part of the array. But have you understood this? Have you understood this, everyone? Has everyone understood this? I'll go to the next. Can I get a yes from everyone if everyone has got it? I'll take one more example. Can I get a yes from everyone? सबको आ गया? Okay, so I'll take one more example. Well, I'll just elongate the array so that you actually understand the concept in much more brief. Okay, you understand the concept in much more brief. So let's take the array where I'll keep it like 1, 3, 4, 5, 8, so that you understand it much better. 12, 15, 16, something like a 17, something like an 18. Okay, so I've taken a very huge array. Okay, I've taken a very huge array so that you now understand the concept much better. So we write down the indexing 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I've taken a n equal to 11 size array. And I'm saying, why don't you find out for me 8? Why don't you find out 8 for me? Okay, so now let's see how does the binary search work for this. So binary search will say, I will initially have a low pointer here. I will initially have a high pointer here. So the low is pointing to the 0th index. The high is pointing to the 10th index. So if I try to figure out the middle will be 0 plus 10 by 2, which will be 5th index. So I see this is the 5th index, which is giving me 10. Is 10 what I'm looking for? No. it's 8. I'm looking for 8. So I will say, hey, nah, nahi hai, idhar nahi hai. So I am very much sure it's not over here. Okay. Now I'll say binary, right? 0 or 1. Either it's on the left half or on the right half. So can I say if the array is sorted and 8 is lesser than 10, I can definitely say, yes, I can definitely say if 8 is lesser than 10, it can never lie on the right half. I repeat, it can never lie in the right half because 8 is lesser than 10. Hence, a part of the array, I repeat, a part of the array gets eliminated, and hence you're just left off with this much. So if you can just omit this part, this will also be omitted. But remember one thing, guys, the high that was standing here will come across and point to right before middle. So that's how you can do it. Okay, that's the first step. You eliminated half of the array. Now if I again take the middle, can I say the middle will again be 0 plus 4 by 2, which is indeed 2. So the middle as of now points to this element. So what I can say is there recursion series from Striver? Yes, recursion series has been uploaded on CodeBeyond. You can check it out. There is already a masterclass of recursion on this channel. You can check it out. So I have a middle. Now, is 8 equivalent to 4? No. And this 8 is greater than 4, which signifies that 8 lies on the right half. So the left half has to be eliminated. So what I'll do is I'll eliminate the left half. So let's eliminate the left half now. So what I did was I eliminated the left half now. Let's eliminate the left half. So the moment I eliminate the left half, I'll be left out with this low and high. Okay. And this time when I try to figure out the middle, let's try to figure out the middle again. So if I try to figure out the middle, I'll get low plus high by 2 as the middle. So that's basically 3 plus 4 by 2 as the middle. And the middle will be pointing here, which is 5. So again I can say that this 5 is not equivalent to 8. And 8 is greater than 5. So again the left part gets eliminated. I repeat, the left part gets eliminated. And the low will move ahead of the middle. So the low will go here. So this time the middle, if you again do, like I'll erase it and do it. This time if you figure out the middle this time will be 4 plus 4 by 2. Hence the middle will be pointing to this guy. Thereby, I can definitely say that if the middle is pointing to this guy, this 8 is equivalent to what I'm looking for. Hence I found that at index 4. Now something very important to observe. Initially, we started with a length 11. Okay. Then we trimmed it down. And it became a length of 5 because we eliminated certain portion of the array. Hence it trimmed down to something as 5. Again I trimmed it down. So the moment I again trimmed it down, it trimmed down to 2. At the end when I trimmed it trimmed down to a size of 1. Okay, a size of 1. So after this, if you'd have trimmed it down, you'd have no array left. Okay, so how many trimming downs did I did? 1 trimming down, 2 trimming down, 3 trimming down. So in a big O of 3, yes, in a big O of 3's time complexity, I initially took n, then I took the half of that. So in time complexity of big O of 3, I was able to find it out. This is nothing but log base to n as the time complexity. Why log base to n? Very simple. If you are doing n to n by 2, to n by 4, to n by 8, and so on to 0, because ideally if you do not find it, it will end up being a 0. So you're dividing by 2 to the powers. What is the maximum power of 2 that you can divide it by? If I'm talking about 11, the maximum power of 2 that you can divide this will be definitely like, basically every time you do n by 2, then an n by 2, so it's basically corresponding equivalent to n by 4. This is equivalent to n by 8. So logically you are basically, if this is n is equal to 11, you end up dividing it by 8 times, like 2 to the power 3 times. So the highest power of 2, that's near to 11 is what you divide it by. Hence the time complexity is log base 2n, because the highest power of 2 is what you are dividing it by. Have you got this? Has everyone got this? Yes, likh do. Has everyone got this? Has everyone got the time complexity as well as the binary search? Can I get a yes from everyone? Can I get a yes from everyone so that I can move to the other portion? Okay, perfect. Okay, now we'll move to the code. Okay, and after that I'll come back and I'll tell you how to figure out the first occurrence as well as the last occurrence. We'll talk about both also, but as of now we will do the binary search code. Okay, let's try to code that. Okay, let's try to code. So basically I can say assume I have an integer find element, and I've been given an array. Yes, I've been given an array and I have an n size. So this is given to you, like you can take it over here, int n scene of n, and then you can take int array of n, then you can definitely take int I equal to 0, I lesser than n, I plus plus, then you can do c in of array of I, then if you want to figure it out, you can do c out find element array comma n, and the element that you want to find x, so you can also find it x. Okay, so just take x2, so x scene of x. Okay, so assuming the input to be okay, so now let's write it. So what is the initial low that we always took? 0. What's the initial high that you took? N minus 1. So let's take low equal to 0. Let's take low equal to 0 and high equal to n minus 1. Now what I can do is, while low lesser than equal to high, why is this condition written? Very important, you need to understand. What is the last case that we did? What was the last case that we did? There was a last case where we ended up at a place where low as well as high were pointing to 8. Had this been some other number apart from 8, then either the high would have, like, you both are standing like this. Okay, had this been some other number, either the low would have crossed high or the high would have crossed low. Like, either of the case will happen. Like, high will come around here and low will cross. So low will cross high, right? If the element is not found, because you shrinked and shrink करते करते बाहर निकल गए, मिला ही नहीं ना, बाहर निकल गए चिपक के. That's why. That's it's very important that you only perform if they are inside boundary, if they have elements. Okay, what's the first thing that you'll do? Okay, that's what you'll do. Now what's the first thing? If this is equivalent to the element that you're looking for, if this is equivalent to the element that you're looking for, you will say, okay, it is found at middle index. So you'll just return it. If you found x at array of middle, return the index mid. Done. If that's not the case, there can be two other cases. If your x is greater than array of mid, so it means never lies on the left half. Okay, never lies on the left half. So what you'll do is low equal to mid plus 1, or else never lies on the right half. hence high equal to mid minus 1. And if this while loop ends, and if this while loop ends, in that case I will say I never found it, hence this line never executed, and I returned a minus of 1. So what I can do is let's quickly write some, and let's keep x as probably 4, and let's see if we can find it out. Cool. So you can see that this element 4 is found at index 3. So if I change it to something like 14, you'll never found it. See, you'll never find it. You got minus 1, right? Have you understood this? Has everyone understood this? Yes, Suhash is correct. That doesn't matter, man. If you write in, like, if I just see this part in Java also, it's written the same way. In Java also, you write the same code exactly. Every Java people will agree, if you write this in Java, it's exactly written the same. Line to line, it is same in Java. Only in Java, what we do is, instead of scene of n, we do this scanner sc equal to new scanner system dot in, right? That's what you do basically. I don't remember so much अभी, मुझे इतना syntax का याद नहीं है, but this is what you do, right? st dot next int, ये तो करते हो, यही तो difference है Java में. You do this in Java, and C++ you do this. Ask any programmer, he will prefer writing C in. That's why I use C++ while teaching. As of now, we are searching, Diptoy Mitro, as of now we are searching in the array. Yes, as of now we are searching in the array. So if you're searching in the array, it's absolutely fine, because 0 and n minus 1 will be in your limit. Yes, system.out.println. I'll come to this, I'll do all kind of question. Yeah, Nishant, we'll do lead code problems tomorrow. But मतलब अगर तुम पहाड़ बना, मतलब पहाड़ पे चढ़ रहे हो, अगर मैं पहाड़ के नीचे से नहीं चढ़ के मतलब सीधा थोड़ी मैं चोटी पे पहुंच जाता हूँ, राइट? यू कैन नॉट रीच द टॉप, राइट? एंड देयर आर लॉट ऑफ पीपल हु डोंट नो बाइनरी सर्च. यू, अभी मैं क्या करूँगा, मैं अगर सीधा लीड कोड प्रॉब्लम उठा के सॉल्व करूंगा, फिर कोई कोई गधा वहां पे जाके बोलेगा कि भाई ये तो इनकम्प्लीट है, बेसिक से नहीं पढ़ाता. तो अपन को भी बेसिक से हम लोग पढ़ा देते हैं, तो दैट कोई अनपढ़ गवार फिर जाके कमेंट ना करे. समझ रहे हो ना? मतलब लोग तो ऐसे जबरदस्ती बिना नॉलेज के कमेंट कर देते कि इनकम्प्लीट है. So yeah, don't just shout lead code problems. Okay, cool. So we have done this. Okay, now let's move across. First question that we will do is, now given an array of duplicates, let's see if you can do this. Given an array of duplicates, okay, find out the first occurrence of x. नोटिफिकेशन नहीं है, बेल घंटी बजा दो. Find out the first occurrence of x. Okay, so CP लेवल का थर्ड डे होगा. CP लेवल का बाइनरी क्वेश्चंस विल बी ऑन थर्ड डे. ठीक है, CP level का binary questions will be on third day. Happy Programmers Day. Okay, now given this question, how will you do this? Assuming the array is something like this: 1 2 2 2 3 4 4 4 and a 5. Assuming this is your stuff, and I want you to tell me the first occurrence of x. Okay, no. I want you to do this using plain binary search. I want you to do this using plain binary search. No STL, nothing. No STL, nothing. Given an array of duplicates, find out the first occurrence of X. Okay. No, 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 no. No, no STL, no STL, no STL. I am not allowing you to use STL. Okay. No for loops. I want plain binary search. It's not कि एक निकाल लिया लेफ्ट में देख लो कहां तक है ना 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 Piyush is saying keep traversing and keep tracking index until L. Map in which will no no no. Array will be sorted. Yes, array will be sorted. Array will be sorted. Yeah, we are learning binary search. So assume everything to be sorted. We are learning binary search. Yes. 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 UIETKUK जो भी तुम्हारा नाम है, it's correct. Ajay, yeah, partially correct. Yes. So understand what do you require. So if I write down this, so it will be 1, 2, 2, 2, 3, 4, 4, 4, 5. Okay. So I'm looking for x equal to 4. I am looking for x equal to 4. So what will happen? So I'm currently standing here. This is low and this is high. Okay. If I write down the indexes, that's 0, 1, 2, 3, 4, 5, 6, 7, 8. So if my middle has to point, the middle will initially point here. Okay. The middle will initially point over here because 0 plus 8 by 2. So the middle will be pointing here. So I definitely know this 3 is not equivalent to this x. This 3 is not equivalent to x. So which portion will get eliminated? The left portion. Yes, the left portion will get eliminated because it doesn't occur here. So just eliminate the left portion and take the low to mid plus 1. Take the low from here to here. So let's eliminate that. So I've eliminated that. Okay. Now once I've eliminated that, now where will the mid light? If I again write down the mid, it will be 5 plus 8 by 2, which is 13 by 2, that's 6. So middle will be pointing here. So at this point, I repeat, at this point, we see that we have an element. Yes, we see that we have an element which is indeed equivalent to x equal to 4, which is indeed equivalent to x equal to 4. So probably you can keep a variable, like let's start learning by keeping a variable. Then I'll teach you the other better way. Let's keep an answer, and initially you can probably keep it as -1. Now the moment you got a 4, the moment you got x, what you will do is you will say, okay, I got it at the index 6. So update this to index 6. Now, what am I looking for? First occurrence. I know I have got it over here. So if I'm looking for first occurrence, I'm very much sure that the first occurrence cannot lie on the right half. If there is a first occurrence, if there is a first occurrence, it is bound that it will be on the left, if only if there is. It can never be on the right because I'm looking for the first instance. So what I'll do is I will eliminate the right half. So the right half gets eliminated. Hence, my high will be pointing to this portion. If my high is pointing to the index 5 and 5, so again I'll try to figure out the middle. So let's try to figure out the middle. So if I try to figure out the middle, this will be 5 plus 5 by 2 equal to 5. So the middle is also pointing here. Again I got an index. I repeat, again I got an index where I say that this guy is also x, and if this guy is also x, since I moved to the left, I got a left index. I got a better left index. Hence, this will be updated to the index 5. Now, I need much better. Or all left mein jao. Go to more left and find out if there exists a first occurrence. Go to more left. So, what I'll do is, if I'm going to more left, I will cross high and I'll go before this. So, high will go to the 4th index now. ऐसे था, I'll take high and move. Okay, so I just took high and I moved across. I just took high and I moved across because I want to move to more left. So the high will be pointing to the 4th index. The low will be pointing to the 5th index. So I come to a point where high has indeed crossed low. So क्या मैं कह सकता हूँ? I was going to the left, and ultimately I crossed over, and hence the answer will be storing, because I was going left, hence the answer will be storing the first occurrence for sure, if there does exist one. How many of you agreed with this? How many of you agree with this? How many of you agree with this? Yes, लिख दो. मजा आया? ट्री सीरीज देखने वाले बाइनरी सर्च क्यों देख रहे हैं? ट्री सीरीज देखने वाले बाइनरी सर्च क्यों देख रहे हैं? मेरे को ये पहले बता के दो. Okay, everyone is agreeing with me? Amazing, guys. Perfect. Superb. Thank you guys for so much of live watching. Like, I'm Unacademy के कोई चैनल पे मुझे नहीं पता होता होगा कि नहीं, बट अपने चैनल पे तो बहुत ज़्यादा होता है. बाकी सब जगह मेरे को नहीं पता आता है कि नहीं. But thank you so much for the wonderful support, man. Absolutely blessed. Absolutely blessed with this wonderful support that you have shown to me. Okay, low equal to 0, high equal to n minus 1. While low lesser than equal to high, I can keep a middle equal to low plus high by 2. And I can say if array of middle, this time to be, can I say if that's equivalent to x, I probably can keep an answer. Okay, I can probably keep an answer as -1, and I can say answer mid pe hai, but still look for a better answer. So I'm trying to modify binary search. You can write it in a lot of other ways, but my aim is to teach you. And the best is, regular binary search, I will teach you in such a way that you just need to do slight modifications into the regular binary search. Okay, so I know if it is at x, I'll store answer as mid, and थोड़ा left चले जाएंगे, थोड़ा left जाके और देखेंगे, ठीक है? If found, let's find somewhere on the left again. Okay, now next, can I say if array of mid is lesser than x, then I definitely know I have to go ahead, or else I can say, like, if this is the case, you can continue basically saying कि और कुछ मत कर, तुझे मिल गया ना, तू वापस चला आया, you got it now you go back. If तुझे नहीं मिला है तो भाई eliminate कर, नहीं तो उल्टा वाले को eliminate कर, simple as that. Okay, so let's see if this is the correct answer. Okay, so basically I'll find first occurrence. Okay, let's keep some other 4s, 4, okay, 2 more 4s. Let's keep 8 and let's keep 4. Let's see if it works. Hooray! सही चल गया. Okay, so we have understood this. Now you can also minimize the code. थोड़ा और code को छोटा भी कर सकते हो, but my main focus is to teach you. the better you will get. You can optimize, like you can write lesser lines of code. Main funda is concept. Once the concept is in your head now, you can write the code by yourself. I don't need to teach you. Okay, a quick question. What if I tell you I don't need this answer variable? Can I always say that low is my answer? Let's see. Can I always say that low is my answer? Okay, let's see if I can always say. Okay, I can. Can I always say low is my answer? Think and tell me. Yes, I can. Yes, I can. Sublime text. ये sublime text है. I'm a big fan of Sublime. Though there are better stuffs in the market, but I'm a big fan of Sublime. Don't know why. I'm obsessed with Sublime. जावेद, डोंट रिमेंबर बाइनरी सर्च इन दैट वे. ऐसे याद मत करो मिड होगा ये होगा, समझ रहे हो? अगर रटने लगोगे तो दिक्कत हो जाएगा ब्रो. रटो मत, कोड्स रटो मत. So can I say this will be always low? Can I say this? Then I have to again take an extra condition where I have to check if that is found or not. So that is why I'll not think of in that direction. I'll keep it as answer. The more you learn, you'll automatically understand low या answer. हाँ, that is why I said कि यहाँ पे फिर तुम्हें एक you have to put in an extra check. You will have to put in an extra check if the element doesn't exist. Okay, that's why I'll not prefer you this way, because you always have to put in an extra check for whether it exists or whether it doesn't exist. Just a minute, कौन है भाई? काम क्यों कर रहा है? क्या हो गया इसको? Switch off. एक सेकंड रुको. एक सेकंड रुको. Okay. If the element is absent, थोड़ा सा रुको तो मुझे इंटेलिजेंस बंद करने दो. ये बहुत ही हैवी हो गया है. मेरा सिस्टम क्रैश थोड़ा हैंग कर रहा है अभी. इंटेलिजेंस टू हैवी. कूल. अरे यार ये कुछ तो इशू हुआ है. नहीं, मैसेजेस स्पैम किए जा रहे हैं. Anyways, so have you understood how to do this? Has everyone understood how to do this? So my next question will be the updated version. Given same, the question will be almost same. Instead of first, what if I say it will be last? Can you do this now? अब तो कर ही लोगे. Given an sorted array of duplicates, find out the last occurrence of x. Tell me, given an sorted array of duplicates, find out the last occurrence of x. Prithvish, both of them have same time complexity, iterative, recursive, so doesn't matter. If you're giving a lot of stack space, it's absolutely okay. Kapish, if you don't do continue, तब भी चल जाएगा, but ठीक है, मैंने लिख दिया. I don't want these lines to be executed unnecessarily. I said ना, code you can modify. If you know the concept, code तुम और छोटा करो, बड़ा करो. Code से क्या, जब तक code चल रहा है, you can write it in a shorter way also. As long as you understand left जाना है, right जाना है, that is binary search. ठीक है? I tell you what will be the solution for this. What is the solution for this, guys? right जाएंगे. Can you tell me the solution for this? Yes. It's a slight change. It's a slight change that you'll do and your code will दौड़ पड़ेगा. क्या slight change है? If in your code, yes, if in your code, if I go across and I just copy paste this and I write last occurrence, and instead of this, if I say low, I'll go on the right and search. Let's find somewhere on the right again for last occurrence. I can definitely do that. And if I write now last occurrence, let's see if this works. Let's see if this works. Okay, works fine. Okay, looks to be working fine to me. So no, hush. Search the element and then try searching on the right. You're looking for last occurrence, right? Yes, perfect. So everyone has understood. So conceptually binary search is clear. How to do that in your normal duplicates, in unique and everything. Is that conceptually clear? How to write binary search in 3 lines. अरे भाई तुम लोग ये clickbait देखना बंद करो यार. Okay, now I'll try to write recursive binary search. What's a recursive binary search? int find element. Okay, so basically in a recursive binary search, you carry low, you carry high, you carry the array. That's what you carry. And what you say is, hey, find element, and you tell them that, hey, listen, I'll give you low, I'll give you high, and I'll give you the array. And whatever you have written over here na, in a while loop, write this. So this while loop, if I just copy paste the previous one, what's the while loop? While loop states low is lesser than equal to high. So base case means in recursion, the case where we stop. So if high lesser than low, we stop and we say element not found. What's the other case? If I say, like, I can probably find mid, and I can be like low plus high by 2, and I can say if array of mid is equal to the element that I'm looking for, is equal to the element that I'm looking for, I can say please return mid. Or else there can be another case where I say that if array of middle is lesser than x, then I definitely know that I have to find element, like find element recurse. I definitely know that I have to find element in recursive on the left part. Hence low comma mid minus 1 will be the high, array comma x, or else you have to return. If that's not the case, then it will be return find element recur. Low will be this, high will still remain, array will remain, and x. लो भाई तुम्हारा 3-4 लाइन का बाइनरी सर्च, खुश हो जाओ. Be happy, you have 3-4 lines binary search, bro. So if I just run it, that will run. No, it's just about knowing. There's no need to use it. What I'm saying is just know it. There's nothing like you have to use it. Just know it, guys. Just know it. That will work. Okay, cool. This also works. So has everyone? नहीं कहाँ 0 रिटर्न कर दिया? सही तो है. सही है. That's correct, bro. Oh, sorry. Okay, now it's correct. Now it's correct. Okay, cool. So as of now, whatever you have learned, is that clear? Iterative, recursive, duplicates, first occurrence, last occurrence. Is that completely into your head? Just tell me that, then I'll move to lower bound and upper bound. पूरी पेज में चला गया. नेक्स्ट क्वेश्चन करते हैं लो बाउंड. Okay, lower bound of x. What is a lower bound of x? I'll write the definition of lower bound. First element that is greater than equal to x. First element that is greater than equal to x. Okay, that's lower bound. First element that's greater than equal to x. For an example, if I give you an array like this, 1, 3, 5, 7, 9, 10. Okay, so I give you x as 7. Then the low bound will be 7, because the first element that's greater than equal to 7 is 7 itself. But the moment I give you x equal to 8, the low bound should ideally be the 9. Okay, and if I give you x equal to 11, then the low bound is no one, because we don't have any element. So have you understood the significance? Have you understood the significance or the meaning of low bound? Has everyone understood the meaning of low bound? Is it clear? Whatever is the first element that's greater than or equal to x, that's your low bound. Is that clear? Okay, perfect. Super. Looks like clear too. Can I get a yes if this is clear, so that I can move across to actually discussing the STL and the inner implementation? Okay, so in C++, I repeat, in C++, there exists. So I'll just write the code here. I don't want to write over there. In C++, if you want the low bound, and if you just give the array, and if you give the n, and if you give the x, there exists something as lower underscore bound, where you give the first iterator. So something like array plus 0, something like array plus n will be your last iterator, and x. And this lower bound, नहीं इनबिल्ड नहीं करने वाले भाई, इनबिल्ड नहीं करेंगे. We will come across and do the binary search. Lower bound, first iterator, last iterator, element x, and subtract the first iterator. That's array of 0. This will give you the index. I repeat, this will give you the index. Now you might ask, but Raj, how will this give the index? So basically, whenever I say array plus 0, means from this guy, okay, and whenever I say array plus n, that means still here. So I'm considering the entire array. Okay, so if I just take this portion, what will happen is, if I'm doing an for 4, there will be an iterator. Okay, there will be an iterator that points to this position. Okay, and what is this position? This definitely will have a memory address. So in C++ or even in Java, if 1 is stored under some block, 2 is stored under some block, I'm writing the array, 3 is stored under some block, 4 is stored under some block. If this guy has a memory address, I repeat, memory address inside the CPU, inside the system, it will have a memory address. If the memory address of that is x, array are stored in contiguous, the nearby will definitely have x plus 1, it will have x plus 2, this will have x plus 3 memory address. Okay, so the moment I write just lower bound, if I don't subtract, the moment I write just lower bound, then I will get, like, if I just write for 4, lower bound of 4, if I say x as 4, I'll get this as x plus 3. I'll get this as x plus 3. The memory address, not the index. Hence, if I subtract the first guy, ARR signifies the first element. So if I subtract the first element, that is x, I will get equal to 3, which will be my index, because 0, 1, 2, 3. Have you understood y minus? What's the iterator concept? This means from the 0th index, this means till the n minus 1th index. N is exclusive. Okay. So have you understood this? I'll tell Sahil, I'll tell that. ये समझ में आ कि नहीं बताओ. Whether like the stream, if you're new to this channel, subscribe कर लेना, like कर देना stream, मजा आने वाला है और मजा आएगा. So have you understood this, the concept of lower bound? So if anyone asks you in future, you'll always see that this is the concept behind lower bound. This is the reason we subtract. Don't just say subtract करते index आ जाएगा. Reason जानो, अंदर का reason. भाई जावास्क्रिप्ट नहीं आता, माफ करो. I don't know JavaScript. Okay. Okay. So one more thing. If I do a low bound of x equal to 10 on this array, if I do a low bound of x equal to 10, then this will point to this position, which is the last. So if this is x plus 1, and whatever is this, it will point to the last index. So the low bound will be pointing to nth index. Nth index is the last index. Like the last index is logically n minus 1. Right after that, there is the nth index. So if a lower bound doesn't exist, in C++, then whenever you do a low bound, it points to the nth index. Make it clear. Make it clear into your head. Okay. Make it clear into your head, guys. नहीं है समझ में? किसको नहीं है समझ में? किसको नहीं है समझ में? कितने को नहीं है समझ में? How many of you did not get it? How many of you got it? Give me a yes, give me a no, so that I get a fair bit of idea. Don't spam unnecessarily. So that I get a fair bit of idea. थोड़ा सा मेरे को बता दो. Okay, Jamin got it. ओके फिर बता देते हैं. नहीं है समझ में? चलो फिर बता देते. कोई नहीं. Okay, let me tell you again. Okay, let's come across again. Okay, so just assume this is your array. Okay, the array's first element is 1, the next element is 2, the next element is 3, the next element is 4, the next element is 5, and the next element is 6, the next element is 8, and the next element is 9. Okay, so assume this is your array. Okay, just for or you can take it till 8 only. Just take it till 8. So generally, whenever you do low bound array of plus 0, so what does that mean? इधर से शुरू करने का रे बाबा. Array plus 0 means from the 0th index. Array plus n means logically should have been over here, because this is n minus 1th index. So the nth index should be here, but it is exclusive of that, means n को include नहीं करने का उससे पहले. So till here. So this guy signifies the first iterator, or the first position that you should start off, and this guy signifies the last position. So first, last, you know the range where you have to find, like the range is basically where you have to find the low bound. Okay, so you know the range. Once you know the range, what does low bound of x give you on this range? Assume x is 4. So only this much, I'm talking about only this much, not the subtraction. So this will give you an iterator. If you don't know C++, still go and watch it. it will point it to here. So they will return an iterator pointing to 4. So logically, whenever I return an iterator, what does that mean? In internal memory of computer or system or server, whatever you call, if this is residing at a X memory space, or let's say some M memory space, M कुछ भी हो सकता है, 1000, 1 lakh, any memory space, कोई एक एड्रेस है, M is in memory address. Okay, M is a memory address. So if the 0th index guy happens to be at the M memory address, the first index guy will be at M plus 1 for sure. Like अगर memory address की value 1 2 3 9 dot 7 है, next वाला 1 2 3 9 dot 8 ही होगा. So this will be M plus 2, this will be M plus 3, this will be M plus 4, this will be M plus 5, this will be M plus 6. So the memory address is what the lower bound will return in C++ STL. Memory address. So once it returns the memory address, I don't need the memory address because it will be a very huge number. It will be an address. I'm not concerned about the address. What I'm concerned about is the indexing, because I know this is the third index. This is the third index where my lower bound exists. So third index कैसे आएगा? If I subtract array, what is array? Array का memory address क्या है? M है. इसका memory address क्या है? M plus 3 है. So M plus 3 is where the iterator points, and if I subtract M, I will indeed get 3, which is indeed the memory address where the element 4 lies, or the index. Indeed the index where it lies. Have you got this now? Have you got the concept of low bound, range, memory, everything now? क्लियर, समझ में आ गया? Is that clear? Is that clear now? Can I get a yes now? अब तो समझ में आ गया होगा भाई, बहुत स्लोली मैंने बताया. अरे मुझे लगा तुम लोग को C++ STL आता है, तो मैं थोड़ा ऊपर जल्दी बोला. I thought you guys know C++ STL. Yeah, learning binary search, you should be knowing C++. Okay. Okay, everyone got it? Everyone. Perfect. So everyone has got that, right? Now, what I'll do is, I'll try to have something specific. Now, what if on this array, I give x as 10. So I know that 10 does not have a low bound. On this array, 10 does not have a low bound. So if that's the case, the low bound will always point to the last index. That's not possible. So in an array, I know indexes are from 0, 1, 2, 3, dot till n minus 1. Those are the indexes in the array. So it will always point to the last index if a lower bound is not possible. Understood now how this lower bound function works? In C++ STL, it will point to the last index, which is n, because n minus 1 is ultimately the last index. So right after that, it will be pointing to the nth guy. It will be pointing to the nth guy if lower bound does not exist. Clear? क्लियर हो गया? अब मेरे को बताओ इसको कोड कैसे करोगे. Now tell me how will you code this. Now tell me how will I code this. जावा में नहीं है इसलिए बाइनरी सर्च सीखेंगे. जावा में नहीं है इसलिए बाइनरी सर्च सीखेंगे. No, Harsh, I'm basically trying to explain all the varieties of binary search so that concept wise you get it clear and we can easily start off it tomorrow by solving problems. I want the concept to be absolutely clear today. Okay, so tell me how will you implement this. If just assume I do not have inbuilt function, then how will you implement low bound? Think and tell me. Okay, think and tell me. Take time and think and tell me. Any paid course of yours to learn DS and problem solving? Yeah, I will find the link in the description. Ramesh will find the link in the description. एजुकेटर प्रोफाइल बोल के एक है, जस्ट चेक इट आउट. एक दिन आपका पूरा सीपी कोर्स कोड वर्स में पढ़ाना. दुर्गा पूजा का विश देखेंगे, सोचेंगे. जावा वाले के लिए कोड करेंगे बाइनरी सर्च. जावा वाले के लिए कोड करेंगे बाइनरी सर्च. विल कोड इट. No, Gagandeep, no. I'm not sure, Gagandeep. I haven't used Java's binary search. Like, I haven't used the inbuilt collections of Java. Like, I'm not a pro Java. I do Java for development, so I don't require binary search on development. We will do problems, Nikhil, tomorrow. We'll do problems tomorrow. Okay. So can I say, what am I looking for? I'm looking for greater than equal to. So let's quickly have a bigger array so that the concept wise I can explain you. Let's have quickly a very big array. Okay, I've taken a very big array, and what I've done is x equal to, what I've done is I'll take x equal to probably let's take 5 for that reason. Let's take 5 for that reason. Now, thinking across, what do I require? I require greater than equal to. Okay, so always make an habit of keeping it as n. Why? Because if a lower bound doesn't exist, I have to return n. So let's keep it a habit of having answer equal to n. Okay, now my low is pointing here, my high is pointing here, my low is pointing here, my high is pointing here. If I just write down the indexes, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so if I take the middle is definitely going to be this. There's absolutely no doubt. Now, can I say this 7? Can I say this 7 is definitely greater than x? What do you think? It's definitely greater than x. If it's definitely greater than x, I need the first. So what I'll do is I'll update this with index 4, and if I need the first, क्या कैसे move करते थे? Come back from that, you will go here. So hence you'll search in the left half because we need the first. If we need the first, we will search over here. Now if I again look for the middle will come out to be this. This time 3 is not greater than equal to 5. Hence I'll take this low and I will search on the right. Let's do a search on the right. देखो कॉन्सेप्ट क्लियर है तो कितना जल्दी हो रहा है, मतलब कोई टफ ही नहीं है, सिर्फ कॉन्सेप्ट्स. So now I have this. Currently the middle will point to this. Again I have a 4 which is definitely not greater. Again I'll take the low and this will move here. Again the array shrinks. Let's shrink it. So the moment I've shrinked it, I just have this. Now the middle is pointing here, and this is something which is definitely greater than equal to 5. Hence I'll say now my next lower bound is 3. I need to go on the left, so high will move, and the moment the high crosses low, I can stop. Have you understood this? Has everyone understood this? Same logic. Left में खोजेंगे रे बाबा, left में ही जाके खोजेंगे. Has everyone understood this? Why did we go on left? The important reason is because I wanted the first element first most, and probably I could have got someone who's equal to. That's why I always went on the left. I always will go on to the left if it's a greater than equal to, because who knows, left में और भी कोई बंदा बराबर हो या फिर बड़ा हो. Has everyone understood this? Yes, tomorrow we will solve binary search problems on sorted arrays. Okay, and next day I'll solve binary search problems on monotonic increasing and decreasing functions. Oh मेरा कमर, सुबह से मैं चेयर में बैठा हूँ भाई. Okay, OP. So do you see concept अगर clear है तो सब खुद ही कर लोगे. If your concepts are clear, you don't need anyone, man. If your concepts are clear, you absolutely don't need anyone. So now if I write the same function, let's see if I can write the same function. Okay, int array int n int x. Okay, so what I'll do is int answer equal to n. ग्रीन सोल चेयर में भी बेटर नहीं, पैसे नहीं है भाई, बजट नहीं है ग्रीन सोल चेयर के लिए. हम अनबॉक्सिंग नहीं करते. I don't buy a green soul chair and unbox it and do a promotion in it and then get the money back. I don't do that over here. I can do that. It's a good idea, isn't it? एक ग्रीन सोल का चेयर खरीदता है, 19,000 का आएगा, प्रमोशन लेता है, ठीक है, एंड एक वीडियो बना देते हैं अनबॉक्सिंग. उस अनबॉक्सिंग में प्रमोशन करते हैं. लो बेटा आ गया चेयर का दाम. कैसा आइडिया है झंडू? कैसा आइडिया है? कैसा आइडिया? and as giving a good idea, just for joke, no offense, no insult to anyone. जिसकी जो मर्जी YouTube सबका है, you can do whatever you want to do. Absolutely nothing against anyone. Answer equal to yes I can. It's not about that. Like ठीक है, कभी कभार अनबॉक्सिंग कर लिया मैंने, यूट्यूब वीडियो उसका किया ना, कभी कभार खुशी होता है, बट हर दिन अनबॉक्सिंग तो नहीं करना चाहिए. दैट इज पर्सनल ओपिनियन अगेन. सी कभी कभी आप खुश होते हो, आप कर लो. आई डोंट हैव अ प्रॉब्लम विद इट, बट लाइक what I personally don't like is if someone is like, again personal opinion, people can do whatever they wish. ऐसा कोई नहीं है कि कोई खराब है. It's just my personal opinion. I don't do that. That's it. Nothing else. Okay. We have array, we have n, we have x. By the way, this is giving the index. Okay. अरे मैंने वही बोला ना, मतलब किसी के लिए हेट नहीं है ब्रो, मतलब it's just a normal stuff that I said, bro. Okay, cool. Yes, lectures are recorded in an academic course. Cool. So that's how you do low bound. Now, next stuff, upper bound. ऐसे फन में रोस्ट करो तो चलता है, अब किसी को हम नीचा दिखा के रोस्ट करो तो वो नहीं चलता है. दैट इज पॉइंट, दैट इज व्हाट आई ऑलवेज ट्राई टू से. ठीक है, आपको किसी की बुराई करने, कंस्ट्रक्टिव बुराई करो वो चलता है, बट किसी को ऐसा नहीं कि भाई, समझ रहे हो ना. सो व्हाट्स अपर बाउंड? अपर बाउंड इज द फर्स्ट एलिमेंट. Okay, upper bound is the first element that's greater than x. Okay, upper bound is the I am a backend engineer. First element greater than x. Okay, so basically what I can say is array equal to, assume the array is 1 3 4 6 7 6 again 8 9. Okay, assume this is your array, right? Is lecture from this will be deleted as quality is too high? पता नहीं भाई, जब तक मैं हूं तब तक तो पता नहीं, मतलब पता नहीं, देख लो तब तक क्या जा रहा है. Okay, so if x is given as 6, then the upper bound will be this guy. If I write down the index as 0 1 2 3 4 5 6, and the upper bound will be 5. Okay, if the x is given as 4, then the upper bound will be 3. If x is given as 5, the upper bound will be 3 I'm writing indexes. If the x is given as 9, upper bound will be n size, which is 7. If x is given as 10, upper bound will still be 7. So go through this and tell me how will you do this. Again, there is a C++ STL. Go through this and tell me how will you do this. Go through this and tell me how will you do this. No, upper bound पढ़ाना होता तो थोड़ी पढ़ाते यार, STL का क्लास कराते. So by the way, there is a upper bound function int ub. Similarly, int array, you can take int n and you can take int x, and you can have an int ub equal to like, upper bound equal to upper underscore bound array plus 0 comma array plus n comma x minus array. Okay, array plus 0 is equivalent to array. Do I need to explain this or बोलूं क्या? Do I need to explain this? No, upper bound will be for 10, the upper, this is index. Yes, login. Okay, so have you like, do I need to explain this? पहले yes या no बता दो. ये explain करूँ क्या? ये तो पता है ना, मतलब similar to lower bound, same concept. It's just the meaning will change. Okay, do I need to explain this? Yes or no? Upper bound मतलब code binary search बताते हैं, but do I need to explain this? That's my simple enough problem. Do I need to explain this? पक्का तो? मुझे वो बॉटल गिफ्ट कर दो, आज मेरा बर्थडे है. अच्छा, हैप्पी बर्थडे शिवो जी. ये बॉटल टूटा हुआ है, टूटा बॉटल लेके क्या करोगे? ठीक है. फाइंड लास्ट इंडेक्स ऑफ एक्स. नो. अपर बाउंड का मतलब ये है, अगर लोअर बाउंड का पढ़े हो, फर्स्ट एलिमेंट which is first element in the array that's greater than x, that is the meaning of upper bound. So like for 6, this is the first index that's greater than, like 7 is the first element, or index 5 is the first index which has an element that's greater than 6. For 4, this is the first index, 6 is the first guy. For 5, 6 is itself the first guy. For 9, there's no one who is greater, so you'll always point to the imaginary 7th index. For 10, there is no one, so you'll always point to the imaginary 7th index. Okay, now let's understand how will you do a binary search. Now, again, let's take a quick example. So, like, is everyone clear with the question? Just a quick question. Is everyone clear with the question? नए बंदे सारे सब्सक्राइब कर लेना, ठीक है? Okay, so just assume the low. Okay, cool. So what am I looking for? Assume I'm looking for x equal to 6. Okay, assume I'm looking for x equal to 6 and the upper bound of x equal to 6. So by the way, x equal to 6 का upper bound कहाँ है बता पाओगे? अगर तुम लोगों को समझ में आ गया तो इसका इंडेक्स बताना, तो upper bound का x equal to 6 का इंडेक्स बताइयो. ट्राई पढ़ा देंगे नेक्स्ट मंथ फर्स्ट वीक या फिर इसी मंथ मैं बात करता हूँ, ट्राई पढ़ा देंगे, ठीक है? ट्राई में तो ताबड़तोड़ ऑडियंस आने वाला है. इफ आई टीच ट्राई, I will get 300+ audience live watching. I can guarantee that. Okay, so tell me what's the upper bound of x equal to 6? Yeah, sixth index. Please review Nishan Char's content, sir. Channel's content, sir. Arey, he doesn't teach us DSA. He says it in open. If you don't want to watch him, unsubscribe, man. Simple as that. जब मतलब देखो, मुझे प्रॉब्लम पता है ऑडियंस से. अगर आपको एक वीडियो में लिखा है अनबॉक्सिंग, आपको पता है, तब भी आप क्लिक कर रहे हो, तो आप यूजर को क्यों गाली दे रहे हो, सॉरी क्रिएटर को क्यों गाली दे रहे हो, राइट? ही हैज ऑलरेडी टोल्ड यू अनबॉक्सिंग वीडियो है, तुमको ही पता है तुमसे देखने से कुछ नहीं होने वाला एक्सेप्ट मोटिवेशन. तुम तब भी क्लिक करते हो एंड फिर तुम गाली देते हो, भाई साहब तू तो क्रिंज बना रहा है. डोंट ओपन मैन. मैं तो तभी देखता हूँ अगर मुझे लगता है कि हाँ ठीक है, क्या मिला भाई देख लेता हूँ, तब मैं देखता हूँ. बट ठीक है, इट्स ओके, एवरीथिंग इज अ पार्ट एंड पार्सल ऑफ लाइफ. सो तुम्हारी मर्जी है, तुम देखो ना देखो, थोड़ी आगे तुम्हारा यूट्यूब चला रहा है, नहीं ना. there's a low, there's a high, right? Where's the middle? Middle कहाँ आएगा? The middle will definitely be at 0 plus 7 by 2, which is this element. So let's keep an answer equal to -1. Let's keep an answer equal to -1. So I see that this guy is smaller than 6. So I have to go to the right. Go to the right. I need greater. Remember, I need greater. I need greater, remember. Okay, so done. Right after that, if I again do a middle, 7 plus 4, 11 by 2. So this is the middle. This time I have a 6 and I still have a 6, but that's equal to, I need greater. So I'll again go to the left, right, sorry. Again delete because I need greater. I'll again delete, right? Now once I've deleted it, so basically I'll again try to get the middle. So the middle will be this. This time I see this 9 is greater than 6. And if it's greater, क्या करेंगे? फर्स्ट एलिमेंट चाहिए, क्या करेंगे? कंडीशन सेटिस्फाई करता है. व्हाट विल आई डू? लेफ्ट जाएंगे. जब लेफ्ट जाएंगे तो ये हाई इधर आ जाएगा एंड इट विल एंड हैव यू गॉट दिस नाउ? हैव यू अंडरस्टूड नाउ? Yes. So whenever there is a condition, make sure जब भी condition satisfy होता है first चाहिए, go left. Otherwise, just make sure you just do a normal thing. So if I write down the code, can I write it something like this? If I write down the code, can I say int answer equal to n, int low equal to 0, high equal to n minus 1, and I'll go in while low lesser than equal to high, and I'll keep int mid equal to low plus high by 2, and assume my if array of mid is lesser than equal to x, I know I need greater, so I'll go this, or else I know greater है. अगर greater है तो इसको store करने का, अरे भाई रैंड इसको थोड़ा कर देने का. Again concept is very important. Done. Now check out this code and tell me if you have understood it. Check out this code and tell me if you have understood this. Check this code out and tell me if you have understood this. अरे ask me anything एक रख दूंगा, उसमें questions पूछना. I'll keep a AMA, ask questions on that. Okay, tell me if you have understood this. Tell me if you have understood upper bound. Everyone? Everyone, get me yes, everyone. Easy. Did not get else part. देखो, अगर ये है, मुझे तो चाहिए greater than x. I need greater than x. So if it's smaller, तब तो sure right में जाना है. तब तो very much sure. If the mid is smaller, like if this mid is smaller than equal to x, then we need to search on right. And if this means it's greater than x, right? It means greater than x. Then we need first. Hence move left. That's it. Simple as that. Yes. When would be classes tomorrow? It'll be at 10. अब समझ में आ गया हिरन? If x was 7, yes. True. True, सुमिता वो चक्रवर्ती. अब आ गया हिरन समझ में? Tomorrow we will be solving all questions on sorted arrays, not on monotonic increasing or monotonic decreasing. Day 3 will be monotonic increasing, decreasing, aggressive cow, painters partition, books partition, all type of questions that are on monotonic increasing and decreasing function. Okay, cool. So has everyone understood this? Now lower bound, upper bound, duplicate, सब clear है concept पूरा? So any questions on arrays you can do this, right? Searching का कोई भी question दे दे, upper, छोटा, बड़ा, सब कर लोगे? Okay. So now, given x, find the number of occurrences of x. Let's see who can do this. Given x, find the number of occurrences of x. So for an example, if x is given as 7 and the array is something like 1, 3, 5, 7, 7, 7, 10. So answer will be 3. Let's see who can do this. Okay. बाइनरी सर्च पे 3 क्लासेस लेंगे. Okay, someone is saying map. Obviously not. By the way, all the binary search that we are doing are login. Okay, tell me what are you thinking as a solution? Tell me what are you thinking as a solution? क्या सोच रहे हो solution क्या होगा? What are you thinking as a solution? Okay, someone is saying traverse and count. So फैजल गलत हो गया ना. रोशन गलत. सुहास गलत. अरे taught you today only. क्या करता रे बाबा, अभी तो पढ़ाया, सोचने का ना. Yes, everyone is going correct. So logically there are a lot of ways to solve it. A lot of people are saying iterate and count. That will be big of n. Like if you write a for loop, something like for int I equal to 0, I lesser than n, I plus plus. If array of I equal to x, counter plus plus. That's big of n. I'm not looking for big of n. The other one is hash map. Again, I'm not looking for that definitely. So one of the things that I taught you was first occurrence and last occurrence. Did I not teach you this, man? Did I not teach you this first occurrence and last? अभी तो पढ़ाया. अरे अभी तो पढ़ाया. Can you not find first occurrence using binary search? If there exist. Can you not find the last occurrence using binary search? If there exist. And can I say the answer will be last occurrence minus first occurrence plus 1 if they exist. If they exist, why plus 1? Because first occurrence will come up as index 3. Last occurrence will come up as index 5. So 5 minus 3 plus 1 will be 3. Right? अंडरस्टूड. नहीं सुभाष, तुमने यही बोला था, लेकिन जितने लोग ने भी बोला ना फर्स्ट ऑकरेंस, उन्होंने ये नहीं बोला कि अगर नहीं हुआ तो. ऐसा भी तो केस हो सकता है जहां हो नहीं, तो चेक करना पड़ेगा कि है कि नहीं. फर्स्ट यू हैव टू चेक इफ इट एग्जिस्ट और नॉट. ओके, देन यू कैन डिटरमाइन. समझ रहे हो? बिकॉज इफ इट डजंट एग्जिस्ट, both of them will return -1, then a -1, plus 1 and then you'll get plus 1. So automatically you'll get 1 occurrence, which is wrong, right? So you have to check if it exists or not. You have to check if it exists or not, right? Okay, good. Do it using upper bound and lower bound का concept. सोच के बताओ. How will you do this using lower bound and upper bound? Think and tell me. How will you do this using lower bound and upper bound? Think and tell me. বুঝতে পেরেছি ভালো ভালো सोच के बताओ दोनों पता है सोच के बताना कॉन्सेप्ट क्लियर हो जाएगा पूरा थिंक एंड टेल मी ओके यस so the answer will be just do a lower bound so that will point here if you do a lower bound of 7 that's going to point here do an upper bound so the upper bound will be pointing here and just make sure to check if the lower bound is equal to not equal to x then say return 0 no existence or else simply return upper bound minus lower bound as simple as that so you can do it in other like a lot of ways so for C++ STL people you don't have to write the binary search there's no need to write binary search you can directly call the lower bound function and upper bound function and you can do this right got this everyone yes I'm not Bengali but I stay in Kolkata okay so cool that's the number of occurrences कोई doubt है any doubts so just I just give this problem so that थोड़ा सा अंदर तक घुस जाए अभी next question let's see given an n probably 26 okay I want you to find the integer square root of 26 the integer square root of 26 is 5 I want you to find the integer square root like not 2 point something I want you to find the integer square root of 26 like any number n got the question yeah that's correct Shubhashish that's correct in C++ interviews like if you're giving an interview yeah absolutely they are absolutely okay if you use interview if you're using STL बस दे विल आस्क आता है ना तुम बोल दो कि हाँ मान जाते हैं ऐसा कोई मना गूगल में तो STL is definitely allowed in every Google interview they encourage you to use STL right in Amazon interviews yeah they might ask you implementation or Google तो encourages STL man they encourage STL no Harsh you don't need to check it because even if it exists even if it goes across and then that's okay right yes first okay a lot of people are saying binary search from 0 to n by 2 okay so I'll give you the constraint and then I'll explain you one more concept over here n is lesser than equal to the highest integer possible n is lesser than equal to like n can be anything from 1 to the highest integer possible like whatever is the highest integer possible n can be anything okay now I'll teach you one more concept also here this will be back in a minute ठीक है मैं थोड़ा पानी लेके आता हूँ तब तक इसका आंसर सोचो कमेंट्स पे लिखो मैं पानी लेके आता हूँ फटाफट Okay, a lot of people are saying binary search from 0 to n by 2. Okay, n by 2 is definitely not the answer, because if n is given as 1, then n by 2 will be 0. 0 cannot be the answer, right? 0 cannot be the answer. Mid equal to n by 2. Okay. 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 Now, what am I looking for? Like, can I rephrase this? Like, if I'll rephrase this, can I say I'm looking for the smallest I? Can I say I'm looking for the smallest I on whose multiplication with itself gives you lesser than n? Can I say this is what I'm looking for? Like, if I rephrase this question to this, makes sense? Makes absolute sense. If I again rephrase this, can I say I can be, since n starts from 1, I can start from 1 itself, go to 2, go to 3, go to 4, and dot 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 till n. Okay, makes what do you think? Makes sense? Like, I can be anything, right? I can be anything between this. Like, for someone like n equal to 25, I can have an answer from 1 till 25. There can be any answer between 1 to 25, right? What do you think? Subscribe कर लो अबे, subscribe कर लो. Sorry, biggest I. Yeah, sorry, biggest I. Absolutely sorry, biggest I. Yeah, biggest I. Not n by 2. Don't. So, in short, can I say this? If I have an n, then I need to figure out the biggest I, and the I can be between 1 to n. Why am I not writing n by 2? Because if n is as 1, then there will be a problem, right? So, can I write this? The biggest I in this range. I can. So, now I have an answer. I know I have an answer. Like, hypothetically, you don't need to create an array. Hypothetically, I know the answer will lie between 1 and 25. 26 for that reason, if n is 26. Now, probably you can keep the answer as 1. Try to keep the answer as 1. Okay. You can optimize this by n by 2, but let's understand the core idea. The core idea is searching an answer when the array is not given. Thinking it is an array. Array नहीं है, but मैं array सोच रहा हूँ. सोचो क्यों मैंने इसको array की तरह बना दिया क्वेश्चन को ना. अब मुझे पता है, I know the answer is somewhere in between this, and I know the condition. I know some answer is somewhere in between this, and I know the condition. Let's implicate. So if I is this and 26 is this, can I say the initial middle will be around 13, and I have n equal to 26. So whenever I do a 13 into 13, it comes greater than 26. But I need lesser than 26. So I am very much sure that the answer will now lie between this. The answer will lie between this. Can I definitely say that the answer will lie between this? I can say that the answer is definitely going to lie between 1 and 12. I think sabko pata hai. Answer will definitely lie between this. Now, again try to figure out the middle. So this time the middle will come out to be 1 plus 12 by 2. The middle will come out to be 1 plus 12 by 2, that's 6. Again, if you do 6 into 6, boils down to be greater than 26. But I want lesser than 26. Again, the right portion will get eliminated and you'll be left out with 1 is to 5. So this time if I figure out the middle, that's going to be 3. Now this is the moment. 3 into 3 lesser than equal to 26. लार्जेस्ट चाहिए रे बाबा, कहाँ जाएंगे? राइट पे जाएंगे. तो अगर राइट पे जाएंगे ये लो इधर से चिपकेगा, इधर जाके खड़ा हो जाएगा. राइट पे जाएंगे ना, लास्ट ऑकरेंस चाहिए, लार्जेस्ट चाहिए. वी नीड लार्जेस्ट, राइट? सो विल गो टू द राइट. सो लेट्स गो टू द राइट. Right over here, if I again try to figure out the middle will come out to be 4. So again, if I do a 4 into 4, that's lesser than 26. By the way, make sure whatever you're taking it, you update it. It's updated. Now 4 into 4 is also lesser than 26. Okay, so again I'll go to the right. Yes, low will go here, and I can update answer to 4. So at this moment, yes, at this moment, I can definitely see something that the middle is also here. So 5 into 5 is also lesser than equal to 26. So answer updated to 5, and I'll again go right, sorry. So ultimately high crosses low, and I'll be having the answer as 5. Has everyone got this? Has everyone got this? Yes, Suhash, yes. मैंने अरे नहीं बना, बट मैं सोचा कि मेरा आंसर इधर है. I thought that my answer is definitely in between that, and I used that property. I did not do anything. I thought my answer is between that, hence I used that particular property. Sure, just ask. नहीं पूछना है भाई. जो नए सब्सक्राइबर्स हैं बोल रहे हैं मैसेज नहीं कर सकते, वो लोग सब्सक्राइब कर लो, मैसेज कर पाओगे. ओ भाई साहब 200 सब्सक्राइबर्स गेन कर रहे हैं हम लोग पढ़ा के लाइव. बहुत सही. Okay, shall I code this? Can I get a yes from everyone? Yes, inbuilt square root also does this, but inbuilt does it in double use करता है inbuilt. Let's code this down. Yeah, let's code this down. Int is square root. Can I have something like probably you can keep it as n by 2 also. That is also okay. Keeping it as n is also okay. Keeping it as n by 2 is also okay. Your wish, guys. Your wish. Thank you, Shubhaji. Thank you. So I know something. If this is lesser than equal to n that I'm looking for, that can be a possible answer. Let's look for some better values. Let's look for some better values. At the same time, if this is not, let's reduce the value, and this is the answer. कितना easily code लिख रहे हैं यार, मतलब binary search ऐसे आ गया. Okay. Okay, now if I just update this question and I say find cube root. If I update this question and I say find cube root. If I update this question and I say find cube root. Find integer cube root. Instead of square root, I say find cube root. How will you do this, guys? How will you do this? Any idea? If I say you find cube root. Yes, I'll come to that. I'll come to that. I'll come to this, guys. Overflow wale mein I'll come. Overflow, I'll come back. So tell me how will you do cube root? Cube root कैसे करोगे? How will you find integer cube root of n? Okay. Yes. So you'll just do a mid into mid into mid. Right. That is what you'll do. Right. You'll just do a middle to mid. Gala mera. What you'll do is a mid into mid into mid. I'll talk about overflows and everything other afterwards. Yes, higher limit can be n by 3. That's okay. So you'll just do a mid into mid. Okay. Now, if I modify this question to 1 by nth root of, instead of cube root, if I modify this question to nth root, how will you do this? If I modify this question to nth root कैसे निकालोगे? I'll do this next day, but अभी homework दे दूंगा. How will you figure out the nth root? That's my plain question. Okay. Any idea? So try out nth root, and this time I don't want integer. I want the exact nth root. That's your homework. We'll discuss this tomorrow, first problem, and then I'll be solving a lot of bunch of lead code binary search problems. Okay, that's what we are going to do tomorrow. Yes. Multiply mid by that times, but multiplying will take big of n. There is something known as binary exponentiation that I'll teach tomorrow, and that will make the multiplication in big O of log n. Okay, like the mid into mid into mid into mid will be done in log n. Yes, not in n. No for loop. We can do using that binary exponentiation. Pow is a method that works in log n. Pow x comma pow I comma n. It's a method that works in log n. You can use that, right? Instead of actually doing running a for loop, pow is a method that works in log n. Okay. Now let's understand something. Overflow condition. That's the last step for today. Overflow condition. कल मैं डिस्कस करूंगा डीप पे. ये बाइनरी सर्च सीखने वाले टाइम एंड स्पेस कॉम्प्लेक्सिटी का क्यों पूछ रहे हैं बताओ. Okay, overflow condition. What is mid? Mid is low plus high by 2. That is what mid is. Okay. Now just imagine, like, what is the maximum value of integer? Let's Google this. Maximum value of integer in C++. Okay, let's Google this. That's 2147. Whatever is this? 2147. कुछ भी एक तो number है. ये छोड़ो, ये टेक्स्ट यहाँ पे चिपका भी नहीं. ओ भाई भाड़ में गया. Okay, imagine I just take this 21474 83647. Imagine I've taken this. Okay, and just in case, I'm keeping everything as integers. I'm keeping integer low and I'm keeping integer high. And there is a certain case. We will be doing this problem in the third day. I'll be encountering such a problem. Just imagine there is a case where the low is pointing here and the high is also pointing here. Okay, I know the middle will also be this. I know that the middle will also be this. But the moment you do a low plus high, that will be integer max plus integer max, which will overflow. Did you understand this? Good night, Shwash. Did you understand this? Integer max plus integer max, this will overflow. Even if the mid is not overflowing, even if the mid will not overflow, because the mid will also be pointing to here, but still this line will overflow. Has everyone understood this? Get me yes, get me a tick. Yes, bata do. Has everyone got this integer overflow? क्योंकि इतना लो खुद ही बड़ा है, सबसे बड़ा नंबर है, बड़ा प्लस बड़ा, twice of बड़ा will overflow. Have you got this? So that is the reason. Yes, that is the reason. A lot of times you will see people writing mid plus, low plus, high minus, low by 2. This is the reason a lot of times people write low plus high minus low by 2. Now you'll say, how is the same? This, how is the same? अरे यार, बचपन का प्यार वाला गाना नहीं सुना क्या? हाई माइनस लो बाई 2, 2 into लो, यही तो होता था ना जब कॉमन एलसीएम लेते थे. Whenever we took common LCM, so 2 low minus low will be low, कट जाएगा. So automatically it will be low plus high by 2. So it's another form of writing this, same form. Now if this is integer max minus integer max gives you 0. Max minus max gives you 0. So the chances of overflow are nil. They are no more overflowing. Hence, you will see a lot of people, just to avoid overflows, like you can use long, that's okay. If you use long or long, then it is okay. But if you're using integers and you are worried about overflows, the best way to handle that is low plus high minus low by 2. दो वड़ा पाव होता है ना, एक वड़ा पाव प्लस दो, एक वड़ा पाव प्लस करके 2 वड़ा पाव. कॉपीराइट आ जाएगा, मैं बचपन का प्यार गाने लगूंगा तो. Okay, have you understood overflow? Has everyone understood overflow, by the way? ठीक है, समझ में आ गया ना सबको? आज का क्लास कैसा था? Before just going off, how was today's class? Binary search explanation, ऐसा मन लाइक इतना डीप में मुझे नहीं पता किसी ने पढ़ाया कि नहीं. प्रॉब्लम्स करेंगे तब और डीप जाएंगे, बट इतना डीप में बाइनरी सर्च का एक्सप्लेनेशन, दिस वाज जस्ट द एक्सप्लेनेशन क्लास, ठीक है. सो जस्ट मेक श्योर स्ट्रीम को देखने के बाद मेरे टेलीग्राम ग्रुप पे इसको डाल दो, जो लोग नहीं देखे वो देख लेंगे. बोल देना कैसा था, थोड़ा फीडबैक दे देना टेलीग्राम ग्रुप पे इफ पॉसिबल. एंड या ठीक है, कल टुमारो वी विल बी डूइंग ऑल प्रॉब्लम्स ऑन सॉर्टेड अरेज. Okay, and next day linearly increasing and all monotonous increasing decreasing. Okay, perfect. 110 by 110. ठीक है, लास्ट स्टफ थोड़ा प्रमोशन मार देते हैं, प्रमोशन करते हैं फिर चलते हैं. So basically tomorrow is when we will do medium problems on binary search, and next day will be hard problems on binary search. That is what we have scheduled for 4 दिन लगातार, संडे मंडे ट्यूसडे वेडनेसडे 4 दिन लगातार स्ट्रीम कर रहा हूँ. And lastly, Career as a Developer subscription, make sure you check it out because hardly 900 rupees for 1 year. And इस पे अगर आपको एक मॉक इंटरव्यू, रेज्यूमे रिव्यू, प्रोजेक्ट रिव्यू, गाइडेंस, डायरेक्ट कन्वर्सेशन मिल रहा है, आई थिंक सोने पे सुहागा है. You won't get this chance, so make sure to use the coupon code Striver. Check it out, 1 year का है. You can just connect to us any day. There is something known as college projects that I generally take. Over here, I definitely take your questions, I review your projects, I review you want to review any other thing, I definitely do it. I have a conversation with you. There is something again which I take every Friday night at 10 p.m. And again, also there is a batch placement 2021 which is going on. I will be starting off with string algorithms this week. So yeah, if you haven't still joined, probably you can check it out because we're going to start with string algos, dynamic programming, graphs, trees, DP on trees, segment trees, Fenwick trees, Moore's algorithm, a lot more is left. Till 1 month, I've just covered the basic topics. All the recordings will be available to you if you still join now. So just make sure you take a subscription. The entire batch will be in English. And if you use the coupon code Striver, subscription पे 30%, 10% off मिल जाएगा. So yeah, you can also check it out if you're willing to learn awesome topics. And if you haven't yet joined the Telegram group, the link is in the description. Right at the end, if you're new to this channel, do consider subscribing. घंटी बजा दो, लाइक कर देना. स्ट्रीम को लाइक नहीं किया ना, लास्ट बार बोल रहा हूँ लाइक करो, अभी लाइक करो. 400 लाइक पहुंचाते हैं, ठीक है, 400 लाइक पहुंचाते हैं फिर चलते हैं. ओके कूल. टुमारो शार्प 10 o'clock. आई माइट बी अ बिट लेट, 10 मिनट लेट हो सकता हूँ, उससे ज़्यादा लेट नहीं होगा. 10 मिनट से ज़्यादा लेट होगा तो समझना स्ट्रीम नहीं होगा, ठीक है. 10 to 10 is when I generally start. So yeah, you can come up and wait. You can try out this problem. You can discuss in the comment section. Homework रहा, कल आके comment section पे discuss करना शुरू कर देना, मैं आके बता दूंगा कौन सही बोल रहा है.